Hello, everyone, and welcome to this week's lesson on El Nino Southern Oscillation. And El Nino Southern Oscillation is something that can be thought of as more climate variability than change, but there are climate change implications to El Nino and La Nina that are important to be discussed in this class because this event has real climate manifestations depending on where you are. Okay. So, having said that, make sure that you look through everything in the lesson folder for the week, and that if you have any questions, you get with me via email or the live office hour or whatever works for you. So, having said that, let's get going. And this is, I think it's a pretty straightforward material, but it's important to know. El Nino Southern Oscillation is what is considered a teleconnection. So a teleconnection, think about a telephone, right? A telephone connects you to someone in the next house, the next town, the next city, the next state, the next country, right? It connects you across space. And a teleconnection in the sense of climate is looking at two different places, and if something happens at either of those, there are sort of consequences to what you observe in terms of climate. So let's get going. Let's put this in presentation mode. And so El Nino is a recurring disruption in the ocean and atmospheric setup, basically, that's observed in the Pacific Ocean, and it affects weather and climate worldwide. Sometimes those effects are good. Sometimes they're really, really bad, depending on where you are. So let's look at what El Nino part means is the warming of the equatorial Pacific off the coast of South America. So roughly Ecuador, Peru, Bolivia, that region there, near the equator, sort of in the western central part of South America. And Southern Oscillation, so it makes up the acronym ENSO, ENSO. This Southern Oscillation is the difference in pressure between Darwin, Australia, and Tahiti. And you might be wondering why Darwin, Australia, and Tahiti. And that's because these are two places that generally have a very, very predictable pressure pattern. And when that pressure pattern changes, then it's telling you something's going on. Does that make sense? It's sort of like if you expect the same thing at a location all the time, and suddenly that thing, whatever that is, changes, then you expect conditions to manifest themselves differently. Okay? So that's what ENSO, El Nino Southern Oscillation means. This right here is called the multivariate ENSO index. Rather than getting into the very dry explanation of what this is, what you need to basically understand is the following. So anything in zero is normal. Zero is what temperatures in the the Pacific Ocean should be. Anything in the red is warmer than normal. Anything in the blue is colder. Now, because you have to have some sort of normal, they have chosen anything between -half and +half as basically normal conditions, meaning neutral. This is what you would expect, the average, with a little bit of room, right? You give yourself like a little range of normal conditions. Anything above this half in the positive is warmer than it should be. Anything below that is colder than it should be. Warm events are considered El Nino. Cold events are considered La Nina. Boy, girl, opposites, get it? So this is all the data that's available from 1980 or the late 1970s, actually, all the way through 2021. And as you can see right now, as of the making of this particular video, We are clearly in La Nina conditions. Back in 2015 and 16, we had a very strong El Nino. And by the way, remember, El Nino warm. This is the hottest year on record. In 1997-98, we had the second strongest El Nino. And this was the hottest year in the entire 20th century. Are you starting to see sort of connections and sort of correlations there? So this has an effect, obviously, on temperature on a global scale, but it also affects other events like tropical cyclones. And we'll get into that a little bit later. So this is during El Nino. I know it's hard to look at this map, but this is Australia, this is the United States, South America, this is the Pacific Ocean, just so that you can sort of focus on what you see here. During El Nino events, the waters in the Pacific Ocean here are much warmer than they should be. During La Nina, they're much colder. Get it? Opposites. During El Nino, the Western Pacific is cooler than it should be. And during La Nina, actually warmer than it should be. So get it? Opposite. Heavy rain, drought, drought, heavy rain, drought. Get it? You're starting to sort of get the idea. It's a way of looking at patterns and manifestations of those patterns. So let's look, and I'm going to show you like 10 different images here. So this is going back to 2016, and I just want you to focus on this area here. Obviously, anything in the orange, yellow, and red means warmer than normal. This is an anomaly, meaning different from what it should be. So in other words, in this case, the ocean is about 3 degrees warmer than it should be. So if it should be 85, it's 88. Or if it's, in Celsius, if it's 20, it's 23. All right? Anything in the blue and purple would be colder than it should be. So this is the year 2016, strong El Nino conditions. Let's forward to late 2016, and it changed pretty quickly to neutral. It sort of averages around anywhere between negative 0.5 and positive 0.5. Remember that? We talked about that little wedge of neutrality, of normality, if you want to call it. This is winter 2017, neutral conditions, a little closer to El Nino. Summer 2017, back to weak El Nino conditions. And then you move to fall 2017, neutral. Late winter 2018, now we switch to La Nina. Notice how much more blue there is. Summer 2018, neutral. Winter 2019, weak El Nino again. Notice you find a bit more orange and red and yellow. Winter 2020, neutral. Fall 2021, they even changed their maps. It's a lot easier to see now. Clearly, La Nina, you see a lot more blue. A lot more blue. So we've decidedly gone into a La Nina pattern over the past year or so, which means the Eastern Pacific is much colder, the Western Pacific is warmer. Okay, so now let's look at both of these events. So remember, La Nina and El Nino, opposite ends, and in the middle would be normal. Make sense? This is one extreme hot, one extreme cold, and normal lies somewhere in between. So, tropical Pacific Ocean. So what you have is changes in air pressure, high to low, low to high, changes in wind, precipitation patterns, and the scale is in months to several years. There's no specific time periodicity where this takes place. In other words, you're not gonna get an El Nino every 2 years exactly. It can vary. You can stay in El Nino conditions for a long time and then go back to La Nina really, really quickly. Okay, so now 3 patterns: normal, neutral, La Nina, cold, El Nino, warm. So let's look at normal. In the Western Pacific, you should expect this: warm, rainy, low pressure in the west, strong trade winds that blow from east to west. And in the Eastern Pacific, this is what you should expect: high pressure, dry, super cold ocean, a fishing industry that thrives. And that's because fish love cold water. Okay? This is what normal looks like. The black arrows are the ocean currents. The green arrows are the wind. Cold water, warm water. This is what normal looks like in terms of the Western Pacific, the Central Pacific, and the Eastern Pacific Oceans. Okay? Now, let's look at La Nina. So you can think of La Nina as strong normal, meaning the Western Pacific is going to be rainier and warmer than normal. And the Eastern Pacific, it's going to be stronger high pressure, colder water still than normal. So in this case, notice how the blue extends further west. The warm is even bigger. There is heavier rain and there is drier conditions here. And this is normally dry, but it's even drier. This is normally wet, but it's even wetter. Okay? El Nino. Well, in the Western Pacific, suddenly you begin to flip everything on its head. The Western Pacific suddenly goes dry. The winds either collapse or reverse. And in the Eastern Pacific, it's suddenly wet and rainy. And that rich, cold, nutrient-rich water that is cold goes away for the most part. And now the fishing goes away as well because the fish either die off or move. So the industry suffers. So you're literally reversing all the norms. And notice how now there's very little blue. It's mostly warm water that's sloshing back. So now this area becomes rainy and this area becomes dry. So you flipped everything. These are some of the consequences of El Nino. Indonesia, Southeast Asia drying out. The Indian monsoon can fail or be very, very weak. And the Indian monsoon is important because Indians rely on that water for agriculture. Okay? There are fewer Atlantic but more Pacific hurricanes. We'll get into that in more detail later. And this is, again, the consequences of La Nina, normal versus El Nino. All right. This is a pretty dated map, frankly, but it shows you that two of the three strongest El Ninos, 1982 and 1998, were associated with significant peaks in temperature. So 1982 was a warm year compared to all the years that preceded it. 1998 was also much warmer than all the years prior up until we got into the 20th century. Okay. This graphic doesn't include the 2016 El Nino. Now, how global warming will affect El Nino is just frankly not very clear. There isn't enough data from satellites, and there hasn't been enough data collected on El Nino events in order to sort of figure it out. Now, many people will argue that if oceans are warmer, then an El Nino event, if it forms naturally, it might be more significant. It might be more highly variable, meaning it has more consequences that are kind of hard to predict. More time and data are frankly needed. Tropical storms. Again, a tropical storm is a cyclonically rotating mass of air that forms roughly in the tropical oceans. Obviously, you need warm water to be 80 degrees Fahrenheit or 26 Celsius. Usually they form in the tropics and they move east to west, pushed by the trade winds. And you need Coriolis effect to spin, right, to get that distinctive spin. And then oftentimes they will move into the tropical and subtropical regions and then into the westerlies, so near where we live, and then they move back to the east. So that's just your typical sort of discussion about tropical storms. Now, how are they affected rather by El Nino and La Nina? So tropical cyclone incidence is generally dependent on what ocean? Is it the Atlantic or the Pacific? And is it an El Nino at the time or a La Nina? And these are the four pretty reliable correlations to make. So in the Atlantic, during El Nino, you have fewer storms. And in the Pacific, you have a lot more. And that's because the overall atmospheric environment is more conducive in the Pacific Ocean for storms to get going. During La Nina events, and by the way, that would be in 2020 and 2021, the Atlantic has more storms. And in fact, the busiest storm season ever was 2020, and the third busiest season, 2021. So this is what happens in the Atlantic. And in the Pacific, you still have storms, you just have fewer of them. Now, during normal conditions, tropical cyclone activity is roughly near average. So there's no obvious distinction between the Pacific and the Atlantic. So that's the correlation between El Nino and La Nina events. Now, El Nino in 2016 was the warmest year on record. So the warmest year on record could mean more warm water in the Pacific Ocean. And if the Pacific gets more frequent storms during El Nino events, then more frequent storms with more warm water might imply stronger events. That's about the only thing you can really say between El Nino, La Nina, and climate change. In the end, climate change may make the fuel more readily available, a warmer ocean. Here's a map of storms across the world, depending on basin, and the Saffir-Simpson scale, which is based on wind strength and damage. Notice where you tend to generally have the most storms in the Western Pacific Ocean, because it is the area of ocean with the hottest water. Recent storms: Katrina in 2005, Michael in 2018. In fact, Michael is now an infamous storm because up until 2018, there had only been 3 Category 5 hurricanes to ever hit the United States. The last one that hit the United States was in 1992, Andrew, and now Michael is in that list. And then, of course, Hurricane Sandy in 2012, which affected New York, New Jersey, New England, Long Island, and so on. So, how would these storms be made worse, possibly, in a climate-changed world? Okay? So climate change cannot explain 2 or 3 extreme events. The media likes to always just default to climate change. It's that fault. It's a little bit more complicated than that. I could definitely accept the argument that climate change is making the oceans hotter, and therefore those events are more possible. Sure, I can definitely buy that. The idea you have to think about longer storm duration, maybe more Category 4s and 5s. There have been hurricanes long before people were around and long before the world was a very industrialized place. We just had to better understand the patterns in this post-industrial, highly developed, highly populated world where humans have a significant impact. Think about a typhoon like Haiyan in 2013, which is one of the strongest recorded storms ever. Even a place like the Philippines, which is used to storms, was really devastated by such an event. Hurricane Maria, which destroyed the island of Puerto Rico as it crossed it diagonally. And when it comes to Maria, this is normal sea surface temperature. This is how much, the yellow line is how much water, how much warmer it was in 2017 compared to where it should be. So there's a lot more energy. The difference is the energy that's available to that particular event. So, climate change may not necessarily mean more storms, but perhaps more energetic ones. Okay? And then we get into this whole idea of the Saffir-Simpson scale, which is a scale that's showing you not only is it dependent on wind, but also the damage that's caused. And we have been seeing a lot more in the 3, 4, and 5 range over the past 20 years. Okay, so that's the lesson. That is the lesson on El Nino Southern Oscillation. It is, again, a teleconnection. And while it's not exact, it's been happening long before climate change was a discussion, the fear is that climate change may make some of these events much more severe. I hope you have a great week. If you have any questions, please ask. Come to the live office hour, or one can be set up for you. Otherwise, I hope you're well, and we'll talk to you soon. Bye.